All right, so here we are at 4.2, video B. We're going to do example 2, maybe a little more challenging one right now. We're going to do, again, we're in systems of equations. We're solving systems of equations. Systems of equations is a system of equations is basically two lines, two equations that we need to solve. In other words, we need to find an x and y coordinate that matches, that makes both lines happy, that point is on both lines. Again, we talked about that system of supply and demand. We've got to make that point or find that point where the system of supply and demand are both content, or a point is on both of those lines. Here's a second example that we're going to go through. Here's the executive summary, I guess. Write one equation as x equals this. In other words, solve for x. You could also solve for y, but we're going to, in this example, we're going to solve for x. Step number 2, place that solution for x into the other equation of your system. And then you'll have one equation with just y terms in it, just y variables in it. Step number 2 is solve for y. Tell me what y is equal to. It should be equal to a number after step 2. Step 3 is take that number for y, put it back into either original equation, and then solve for x, and you should be done. So let's go past the example we did in A, and here's B, a different system. So the equation says, or I guess the instructions say, solve this system. So solve means tell me what x and y are. Don't stop at just solving for x. Don't stop at just solving for y, because the system of equations includes an x and a y. So make sure that if I say solve, give me your x and your y. So we've got an A, we've got B. Here's our A line, or A equation, x plus y equals 4. B equation, negative 5x plus 3y equals negative 12. And if we're using this substitution method, then which equation, A or B, do we solve A or B for x equals this? Make it easy on yourself. So I would not solve B for either x or y to use the substitution method, because you'd have a whole lot of fractions, plus it'd be a couple of steps. So I would say take our A equation and say, you know what, x plus y equals 4, and you know what, just solve for x. Let's subtract y on each side, subtract y on each side, and I'll have x equals 4 minus y. And now we've solved for x equals something. In our previous example, in video A, we had one solved for x already, but this one required us to take either A or B and solve A or B, line A or B, for x. And sure enough, we did. So now we've got x equals 4 minus y. So now in our second B equation, I'm going to say, now let's take our B equation and rewrite it, negative 5x plus 3y equals negative 12. I do that only because if we take this and try to copy it down here, as well as include the x as 4 minus y, then we might have, it might lead to maybe more mistakes. So that's why I take the first step and just rewrite it. Now substitute in, instead of x, we're going to call it 4 minus y. So we'll call it x equals 4 minus y. And now we'll rewrite everything else, plus 3y equals negative 12. And now the only difference is x is now 4 minus y, because we've taken that definition of x from our A line and substituted it in. And now we've got an equation in the Christmassy colors of red and green that has just a y variable in it. There's no x's there, so now we can just solve for y. We do that by distributing first. Negative 5 times 4 is negative 20. Negative 5 times negative y is negative times a negative is a positive. 5y plus 3y doesn't change, equals negative 12, doesn't change. Now we combine like terms. Negative 20 plus 8y equals negative 12. And we move the terms over to the right side, the constant term, by adding 20. And all we're doing really is just solving now equations. I've got an 8y equals negative 12 plus 20 is positive 8. Divide by 8 on each side to get 1y on the left side equals 8 divided by 8 is 1. And there, we're halfway there. We've got our half of our solution. But don't stop just here, because I've asked you to solve the system. Solve means tell me what x and y is. So we know what y is. We don't know what x is. So I would take, you can now take your y value and substitute back in for either one of these variables, or sorry, you can take your y value into either one of these equations and solve for x. It doesn't matter which one it goes into, but the easier one is probably a. So I would start with a and say, well, here's my a is x plus y equals 4. Y equals 1? All right, well, substitute in y equals 1. X plus, green, y equals 1 equals 4. Subtract 1, subtract 1. X equals, plus 1 minus 1 goes away. 4 minus 1 is 3. And there's our solution. X equals negative 3. Now we can double check by saying, starting with a, and you could write it out, but you could just as easily take a look at it. 1 plus 3, or sorry, 3 plus 1 equals 4. Yes, it does. So that checks out. So now we can take a look at b and say, well, does b check out? Here's our b equation, negative 5x plus 3y equals negative 12. And we're going to substitute x equals 3 and y equals 1. So negative 5 times x, 3, plus 3 times y, 1, equals, with a question mark, negative 12. Negative 5 times 3 is negative 15, plus 3 equals negative 12 with a question mark. Negative 15 plus 3 is negative 12 equals negative 12. Sure enough, it checks out, and that's a solution for our system. So we've checked our solution, we've double checked it, and we've substituted in, we've solved our system. Solve this system. I'm going to ask you to do this one. Bring it into class and show me that you've done the work on using the substitution method for this one. This one, I would say, again, we've got to solve one of them for one of the variables, and I guess we've got to kind of make our life easy. So I would recommend taking a look at equation B and solving for y, because that has the variable, or that has the coefficient of negative 1 in front of it. That should be a lot easier to modify and solve for without having to work with fractions. So solve b for the variable y, and then substitute into a and work with the equation for a.